Hi, in this video I am going to use engineering statics again to find the forces that are exerted on a knot in a facet knot wrench in one of these wrenches when applying 125 pound-inch of moment or torque into the handle. So let's go ahead, let me go ahead and draw this portion of the tool. This is our point C. Let's say at point C we have a force at point C in y direction and a force at point C in x direction, and at this point let's say we have a force at point B in y direction and force at point B in x direction. And also let's look at the knot itself. So let's say this is our knot. And this point is again point B. So let's say this is our force at point B in x direction, and this is our force in point B in y direction, and this is our point A on a knot. Let's say that this is our force in point A in x direction, and this is our force at point A in y direction. Now using the engineering statics in order to find these forces, again the conditions, the summation of all the forces in x direction must be equal to 0. The summation of all the forces in y direction must be equal to 0. And the summation of the moment with respect to any point in our system must be equal to 0. So let's look at this portion. So summation of the forces in x direction got to be 0. So the forces, let's assume that the right direction is the positive direction. So we are going to have force at point B in x direction minus force at point C in x direction must be equal to 0. So from here we see that the force at point B in x direction is equal to the force at point C in x direction. So in both this point and that point, that plane, the forces in x direction are equal. So this is also equal to the force at point B in x direction, and this is force equal to force at point C in x direction. And if we take the summation of the forces in y direction, let's assume the top part is positive. So we have force at point C in y direction minus force at point B in y direction equal to 0. So the force in y directions in both point B and C will be also equal. So this is also equal to the force at point B in y direction, and this is force at point C in y direction. Now, let's go ahead and take a moment with respect to point C. We know that the summation of the moment with respect to point C must be equal to 0. So moment, again, by definition, was the force multiplied by distance. So the first force is this one, so we are going to have this force and is going this direction toward point C. So let's assume that this direction is positive. So force at point B in y direction is going the negative direction, so it will be minus force at point B in y direction multiplied by the distance between point B and point C multiplied by this distance, which that distance is 3/4 inch. So multiplied by 0.75 inch. Then the other force is this force, which is going the positive direction. So it's plus force at point B in x direction multiplied by the distance between point B multiplied by this distance, which that distance is 1/8 of inch plus 1/2 of inch. Okay, so that will be 1/5/8 of inch. So that means multiplied by 1.625 inch. 1/8 plus 1/2 is 5/8, and 5/8 is, yes, 625 inches, equal to 0. So from here, the force at point B in x direction will be equal to 0.75 force at point B in y direction divided by 1.625. So 0.75 divided by 1.625 will be equal to, so the force at point B in x direction will be equal to 0.46 multiplied by the force at point B in y direction. So this is equal to 0.46 force at point B in y direction. So this is also the same, equal to 0.46 force at point B in y direction. Now let's look at the knot itself. The moment at point A, the moment apply, let's go ahead and take the moment toward this point A. The moment apply at that point, at point A on a knot, will be equal to the same moment or torque that we are applying into the handle. So the moment applied at point A will be equal to 125 pound-inch. So let's go ahead and find the moment at point A. At point A, the moment of this point with respect to point A will be 0 because it is aligned. It is aligned point B and point A on the same line. So the only moment we have is force the moment, summation of the moment at point A must be equal to the same moment that we are applying into the handle, must be equal to 125 pound-inch. So let's assume that this direction is positive. So we are going to have force at point B in X direction, which is going on the positive direction toward point A, multiplied by this distance, which is 1 1/8 inch, multiplied by 1 1/8 inch, which is 1.125 inch, must be equal to 125 pounds. So from this equation, we can find that the force at point B in X direction is equal to 125 pound-inch divided by 1.125 inch. So that would be 125 divided by 1.125 will be equal to 111.11 pounds. So the force at point B in X direction is 111.11, which is also, so this is 111.11, this is 111.11, and the force at point B in Y direction, we know that the force at point B in X direction, we found that is equal to 0.46 of the force at point B in Y direction. So 111.11 is equal to 0.46 at force at point B in Y direction. So the force at point B in Y direction will be equal to 111.11 divided by 0.46. So this is equal to equal to 241.55 pounds. So this is equal to 241.55 pounds, which is the same. This is 241.55 pounds, which is the same here, 241.55 pounds. Now, if we take the summation of moments in y direction on that knot, we will see that this will be also equal to 241.55. And FAX will be also equal to 111.11. So these are all forces applying into the knot in those range. Now I had one question. Somebody asked me what is the magnitude of a force at each point. So that is the magnitude. Let's say, for example, at this point A, we have, if we refer to vector mechanics, we have force A in y direction, and we have force A in x direction. The magnitude of a force at that point is this force, which that force is divided in two portions. One portion along the x direction, one portion along the y direction. So if you remember, in a right triangle, if we call this side as the force on point A, force on the point A square will be equal to force at point A in x direction square plus force at point A in y direction square. So the magnitude of the force at point A will be equal to the square root of a force at point A in x direction square plus force at point A in y direction square. So which is equal to the force at point A in x direction, which is 111.11 square, plus the force at point A in y direction square plus 241.55 square. So the magnitude of the force at point A will be equal to 111.11 square plus 241.55 square, then the square root of that so it would be 111.11 square, which is 12 to the 45.43 plus 241.55 square plus 58 346.40 then the square root of that. So this force will, the magnitude of a force at point A will be 265.88 pounds. And this is 111.11. And this is 241.55. So if you need to find the magnitude of a force on each point, this is how we have to find it. I hope you liked it, and for next video we are going to have same pipe, the 1 1/4 inch diameter pipe on one of these pliers. So when we applying, let's say 65 pounds of force into the handle, we're going to find out what the forces would be exerted on that pipe in this type of ply. So see you all later.